In continuation to what we dealt with last time, we said it is important for a drug to produce its desired effects to be available at its site of action, the receptor's locus of action, in sufficient concentrations at the right time and for an appropriate time period. And we said we just simulated that a drug is needed to act here on this part of the body. And it is taken by mouth. How does it get there? How does it get from ingestion or taking, swallowing it until it gets to this point here? It has got to go through the GIT, gastrointestinal tract, to be absorbed from the intestines, and everything absorbed from the intestines must pass through the liver. That's called first pass. It must get there, and from the liver, if it is not broken down or metabolized, it will get to the circulation, and then through the circulation, it will be transmitted to its site of action or locus of action here. But for any drug absorbed from the intestines, first of all, it has to be absorbed across a cellular line, the epithelial line of the intestines. And it has got cross cells. Luckily, we said before, that all the cells that a drug may encounter to cross either into the cell or outside the cell, in both cases it has to cross the cell membrane, the membrane is the same. Cell membranes are composed of a bilayer of lipids, lipoproteins. Every cell membrane, all cell membranes, no matter what the cell is the basic composition of, constituent of, the lining or the wall of the cell, that is the cell membrane, is composed of double layers of lipids. Bilayer, lipo, double layers of lipids. Sandwiched within them are proteins. So all cell walls are composed by bilayer lipoid barriers sandwiched into them. Within the two layers is a protein, just like a piece of bread, both sides of the bread, and meat is inside. So this is the composition of a cell wall. Therefore, anything we deal with about any cell wall will be of course, naturally will apply to other cells. Now, let us imagine that the drug is within the cell, the intestinal lumen, ready for absorption across the intestinal wall. All drugs or even food materials will cross by what is called diffusion, passive diffusion. Passive diffusion means there is no energy expended, and it will only depend upon the difference of concentration, just like osmosis. The higher the concentration on one side of the wall, the more easy and rapid it is going to cross into the other side where the concentration is low. That means it will go again towards the gradient of concentration. Okay, if a drug is lipid soluble, of course, naturally, it will have better chances of being absorbed. Because as we said, the wall, the lining of cells, the cell membrane, is the lipoprotein. So you need agents which are highly lipid soluble to cross this wall, the cell wall. almost all drugs are weak bases or weak acids. And these are usually undissociated, non-polar, non-electrolytes. And this is the best quality that a drug should possess to be lipid soluble, that dissolves in fat. So the best qualities that a drug should acquire is to be non-polar, lipid soluble. These are electrochemical properties, electrochemicals of the drug, which the drug should possess, should be non-polar, lipid soluble. Conversely, if a drug is dissociated, ionized, it has minimal chances of crossing a cell membrane. This is important. It has to be non-polar and lipid soluble. And of course, as we said, wherever it wants to go, it will find the same cell membrane, same core structures, and all qualities and rules will apply to it. Now, if, for example, we want a drug, most of the drugs, as we said, are non-polar. We want a drug not to cross the cell, not to cross the membrane, to stay on this side of the cell membrane. Then we will have to dissociate it, to ionize it. It has to be, once it is ionized, it has minimal chances of crossing the cell membrane. And this property is made use of clinically, in practice. Because sometimes you want a drug to stay within the lumen of the intestines, not to be absorbed, because it will have to act. You want it to act within the lumen. Let us suppose you want it to act on worms. The worms are all abiding, living inside the lumen of the intestines. Therefore, the longer these worms are in contact with this drug, the better your chances of anti-emetic effect. So, any drug that dissociates within the intestinal lumen has minimal chances to be absorbed into the circulation. And this is sometimes desired, as I said, in case of antiemetics. Streptomycin, one of the antibiotics, or all mycins almost, they dissociate very strongly within the lumen of the intestinal wall, within the lumen of the intestines. They dissociate all the mycins, particularly streptomycin. This sometimes is needed in surgery. You want to sterilize the GIT with streptomycin. Therefore, you want a formulation that is not likely to be absorbed from the intestines. That is, conversely, is likely to stay within the lumen of the gut to sterilize this gut. And this is made use of, as I say, in many cases when sterilization, asepsis of the GIT is required. Another example, let us suppose a drug is basic, alkaline in nature, and it has been filtered in the glomerular tubules with the filtrate, the glomeruli, and it has been filtered with this. Of course, if it is basic, as I said, alkaline, it will be reabsorbed from the glomerular tubules back into the circulation. But sometimes we want it to go out with the urine. We don't want it to be reabsorbed. We want it to go out with the urine. So if you know its, its quality as basis or acid, we say here it is a base, we acidify the urine. You have to acidify the urine so that it will so that the alkaline nature of the drug will help in dissociation of that drug. And once it becomes ionized, as we said, and dissociated, it is unlikely to cross cell walls, barriers. This is an application of this phenomenon, that you ionize a drug that has been filtered in the glomerular filtrate to help in getting rid of it with urine. Of course, the reverse is true if you want it. If it is basic, you ionize, you acidify the urine. If it is acid, you alkalinize the urine. And in that way, you confine the drug to the tubular lumen, and it will be passed out with urine and out of the body in consequence. So, a drug to rapidly cross a cell wall has to be non-polar and lipid soluble. If it is dissociated and ionized, it will be non-lipid soluble and it will remain on this side, it will not cross over. Thus, we know now that there are certain qualities required to be possessed by a drug to rapidly cross a cell wall.